1.2 Thermometers. B. Calibration. An unmarked thermometer has to be calibrated. To calibrate a thermometer means to mark a scale on it. Experiment 1A. Calibrating a thermometer. An unmarked thermometer is put into ice water mixture and boiling water in turn in the following experiment. All thermometers make use of temperature-dependent properties of materials, also called thermometric properties. For example, when temperature rises, many substances expand. Some change their resistances, and some change their colors. These substances may be used to make a thermometer. 1. The liquid in glass thermometer. A. How it works. A liquid in glass thermometer makes use of expansion of liquid. As the measuring liquid expands at higher temperature, the length of liquid column increases, and we may then read the temperature from its scale. Mercury is used in liquid in glass thermometer as mercury expands and contracts uniformly with temperature. A mercury in glass thermometer responds rather quickly to temperature change, because mercury, as a good conductor of heat, conducts heat very well. Water is not used as a measuring liquid as it does not expand linearly with temperature rise, especially between 0 degrees Celsius to 4 degrees Celsius. B. Calibration. An unmarked thermometer has to be calibrated. To calibrate a thermometer means to mark a scale on it. Experiment 1A. Calibrating a thermometer. An unmarked thermometer is put into ice water mixture and boiling water in turn in the following experiment.
Put an unmarked thermometer in a beaker of pure melting ice. Make sure the bulb of the thermometer does not touch the beaker. Mark the liquid level of the thermometer after it becomes steady. Repeat the steps with a beaker of pure boiling water. Divide the length between the two markings into 10 equal divisions. Each division represents 10 degrees Celsius. Use this calibrated thermometer to measure the temperature of tap water. What is the reading?
As it takes time for thermal equilibrium between the thermometer and the beaker of water, the liquid level should be marked when it becomes steady. Example 1. Calibrating a thermometer. The table gives the length of the liquid column at different temperatures. You should be able to read the unknown temperature directly from the graph or calculate the unknown temperature by assuming a linear relationship between the length of liquid column and temperature. C. Mercury and alcohol in glass thermometers. They are common liquid in glass thermometers. Mercury in glass thermometer can measure higher temperature and provides quicker response to temperature change. But mercury is poisonous. We have to be careful not to break a mercury in glass thermometer. On the other hand, alcohol in glass thermometer can measure lower temperature, and alcohol is not poisonous, but it responds more slowly to temperature change. Clinical thermometers in the past are also mercury in glass thermometers. There is a level band called constriction near the bulb to stop the liquid running back to the bulb, so the temperature can be read more accurately. Clinical thermometers are designed to measure body temperature, and so it has a very small range around the normal body temperature. It is sterilized by alcohol, but not boiling water, as high temperature may break the thermometer easily. 2. Different types of thermometers. Different thermometers make use of different temperature-dependent properties. Liquid in glass thermometers make use of volume change of liquids. Infrared thermometers make use of intensity change of infrared radiation. Rotary thermometers make use of curvature change of bimetallic strips due to different expansions of metals. Resistance thermometer and thermistor thermometer make use of their resistance changes. And liquid crystal thermometers make use of color change of liquid crystal with temperature. Example 2. Rotary thermometer. Rotary thermometers are robust. It is commonly used in ovens and freezers. Exam link 1. Plotting a graph. The resistance R of a resistance thermometer changes with temperature. In this case, the resistance changes linearly with temperature. We may read from this straight line graph the unknown temperature when R equals 40 ohms, as in Part B. Do check point 2 below.